This is my individual report. Component of transportation. My study case is pipeline transportation. Sabah Sarawak gas pipeline explosion in 2014. My name is Muhammad Hafizi bin Nazri. I'm from BA 1114 4C. For the introduction, pipeline transport is one of the most efficient method of transporting oil, natural gas, and other petroleum products over long distance. In Malaysia, pipeline network play a major role in supporting the energy sector, particularly in East Malaysia. One of the most important network is the Sabah Sarawak gas pipeline, SSGP, operated by Petronas. However, incidents such as the 2014 SSGP explosion in Lawas, Sarawak have highlighted the risk, safety challenge, and need for strongly policy enforcement in pipeline transport. You can see a pipeline photo in here. For the characteristic of pipeline transportation, first mode, underground or above ground pipeline. Second, cargo, natural gas, crude oil, refined petroleum. Third, flow system, continuous flow using compressor or pump stations. Fourth, distance, suitable for long distance and remote locations. For the safety feature, sensor, leak detection system, emergency shutdown valve. And for the cost model, high initial investment but low operating cost. Now I will talk about advantage and disadvantage of pipeline transportation. For the advantage, have a low operational cost after installation, safe and stable flow of gas or product, not affected by traffic or weather, environmentally cleaner compared to truck or ships, high capacity for transporting gas or oil. For the disadvantage, very expensive to build, leak detection challenge, especially in remote forest area, high risk of explosion if pressure or corrosion occurs, environmental damage if leak happen. For last, difficult maintenance in rural and forested area like Sabah and Now I will explain about infrastructure and network. Major pipeline network in Malaysia, Sabah Sarawak Gas Pipeline SSGP 512 km from Kimanis, Sabah to Bintulu, Sarawak. Peninsula Gas Utilisation PGU, West Malaysia largest gas distribution network. Kimanis Kota Kinabalu Pipeline. For the policy, Petroleum Development Act 1974 PDA, Petronas Control Ownership and Regulation. Second, Environmental Quality Act 1974, Pollution Prevention. Third, OSHA 1994, Workplace and Operational Safety. For the last, Factory and Machinery Act 1967, Safety of Mechanical System. They have one example of pipeline. Issue and challenge in pipeline transportation. First, corrosion and wear and tear in tropical climate. Second, landslide and soil movement in hilly Sabah and Sarawak. Third, sabotage of vandalism in remote area. Fourth, delay in maintain response due to distance. Fifth, aging pipeline with pressure irregularities. Sixth, coverage in dense forest. 7. High pressure build up that can cause explosion. For the stakeholder, government, DOSH, Department of Occupational Safety and Health, DOE, Environmental Agency, Ministry of Energy. For the operator, Petronas Gas Berhad. for the local communities, village in Lawas area, environmental group, forest and wildlife NGO, and for the consumer, LNG industry power plants. For my case study, I will talk about Sabah Sarawak gas pipeline explosion in 2014. This case was happened in 11 June 2014. This location at Lawas, Sarawak. That pipeline called Sabah Sarawak Gas Pipeline (SSGP). For the operator is Petronas Gas Berhad. For the incident summary, a gas leak caused a major explosion and fire along a remote section of the pipeline. The accident forced nearby village to evacuate and result in temporary disruption of gas supply to Bintulu LNG. Cause of the explosion are pipeline pressure irregularity, possible soil movement due to heavy rain, structural failure at the affected section, weakness in pipeline integrity monitoring in remote regions. For the impacts, human and community impacts, residents forced to flee for safety, fear and loss of trust in pipeline safety, loss of crops and damage to nearby forest land. For the environmental impact, fire damage surrounding forest area, emission of gas into the atmosphere, potential soil contamination. For the economic impact, temporary halt in gas delivery to LNG facilities, repair costs and investigation costs for Petronas, disruption to downstream industry. For the operational impact, shutdown of pipeline, emergency response activation, full investigation into pipeline integrity. For the stakeholder interaction, Petronas activate emergency shutdown, DOSH and DOE conducted safety inspections, local government assisted in evacuation, community leader coordinates communication, environmental groups monitor damage. This interaction affected both the efficiency and safety of pipeline operation. Good coordination helped reduce casualties, but the accident highlight the gap in monitoring remote pipeline. This is example of map pipeline in SSGP. For my recommendation, first, we can improve pipeline monitoring technology, install more smart sensor. Second, use drone for forest route inspection, real-time leak detection system. For the second, strengthen maintenance, more frequent inspection in soil movement zones, upgrade aging pipeline segments. For the third, community engagement, educate villagers on emergency procedure, provide compensation or safety briefings. For my conclusion, pipeline transportation is vital to Malaysia energy security, especially in Sabah and Sarawak. However, incidents like the 2040 SSGP explosion show that pipeline system requires strong monitoring, safety policies and cooperation from all stakeholders to prevent disaster. A well-maintained pipeline combined with active policy, technology and community engagement can significantly improve the efficiency, safety and sustainability of this transportation mode. Thank you.